Anybody got traffic leaving an VPC? It needs to be secured? Yes? Yes? Good. Lovely.
Thanks, Daryl, and hi everyone. So I'm Peter, I'm a security architect that focuses on the cloud. Can you hear me? Microphone's too close, too far away? It's gone. Okay. So, it's a bit of a mouthful securing traffic leaving a VPC. But at the end of the day, I guess the truck kind of explains that sounds better. What we actually accomplished with a large customer, can't name them unfortunately, who had this challenge. So, just firstly a bit about Sophos, because I know most people have probably seen all the sponsors and so forth, but we're actually a security company. We've been in the AWS space since about 2011. The main solution that we have in the AWS environment is a UTM, which is a Unified Threat Manager, which is basically it's a file with a lot of extra stuff. 3 different deployment models. We do actually bake our own AMIs. We don't do any of this frying business, but we have different AMIs, different regions, different purposes, and so on. And we are, as you can see, an advanced technology security competency partner. So, this particular customer, about probably 18 months ago, 12 months ago maybe, they came to us with a need. They have thousands, probably tens of thousands of workspaces users, plus also EC2 instances that needed to get out to the internet. Now, the challenge that they had was that a lot of these workspaces users in particular were actually impaired VPCs, and these VPCs didn't have internet gateways. Now in a second I'll talk about transitive routing and one of the restrictions with it. So the other thing that they had to deal with was how do we handle the varying loads, because we could potentially put a firewall or a number of firewalls up in AWS, but what happens if all of a sudden we get 10,000 users or 20,000 users logging on at the same time? It's possible that the firewalls may not be able to cope, they may fall over, they may just slow down. I've seen that myself with an organisation. They were running a firewall, one of our UTMs, and they had a developer do some testing. They didn't know about it, and the traffic basically flooded the box and it ground to a halt. And I said, well, what size instance were you running? And they said, an M3 medium. And I said, okay, you better upgrade. So it's very easy to actually underspec or not have enough capacity to deal with varying loads. The other thing is, if you over-provision, you can end up spending a lot of money. Okay, so we want to try and do things in an efficient and cost-effective manner. You may also have the requirement, well, they had the requirement saying we wanted certain subnets to be able to go out, but these other subnets, these other users, not so. So, some of the challenges that we faced, well, they faced, I should say. Routing, this is probably the biggest one. So, getting the traffic across the parent connection and out to the internet, easily. The transitive routing restriction, so I've got a slide shortly which shows this, but if you've got 2 VPCs and they're connected by a parent connection, you can't basically point traffic in VPC 2 through VPC 1 to get out to the internet and vice versa. Okay, some other issues, of course, was scalability, making sure that there was enough capacity, using things like auto-scaling to make sure that there were sufficient firewall instances running to handle the load, being able to self-heal in the event of failure of one, or perhaps even the failure of a complete AZ. Okay, and then the other thing was being able to automate as much as possible and support the DevOps goals. So, transitive pairing. As you can see, and as I mentioned, you've got 2 VPCs. Now, you've got a user down in VPC B, no internet gateway, no NAT gateway, nothing. So they want to get out to the internet. They can't go through the parent connection through VPC A and out to the internet, because Amazon, basically, or AWS won't allow it. Anyone know the name of that character, by the way? No? Okay. I was trying to remember myself. It's from Little Britain. Might be Vicky or something like that. It's actually a bloke. But yeah, computer says no. So that's no good. So if you've got your instances or your workspaces, desktops, and they're sitting in a VPC and it's paired, doesn't have an internet gateway, how do you get traffic out through your firewalls, which are in another VPC, make sure that the traffic's in accordance with firewall policy, and stops them going to sites that you don't want them to go to. How do you do that easily? And how do you do that in particularly transparently, as opposed to having to set things like explicit proxies and so forth? How do you make sure that the infrastructure you've got in place, the security infrastructure you've got in place, can actually handle the changing loads? Because especially with workspaces, you can have tens of thousands, and this organisation was in the several tens of thousands. How do we address resilience and scalability? Okay, 10 or 15,000 users decide at 9 o'clock in the morning they want to get out and just check on the news. This is a US organisation, by the way, not an Australian one. How do we make sure that the firewall solution can actually scale and cater for that load? So what we want to do is we want to use auto-scaling, and we want to be able to self-heal. So if one of the firewalls falls over, has a kernel panic or whatever it might be, a new one will come up quickly, get the configuration automatically, and take over. And you, as an admin, wouldn't even need to know about it. So what are some of the options? One thing that you might think of, well, hang on, we've got these things called elastic load balancers. Maybe we can just create an ELB internally and point our route to it. Can we do that? We'll find out shortly. Well, the other thing we could do also is we can deploy lots of firewalls and proxies to make sure that there's always going to be capacity, but cost. Okay, you don't want to spend a lot of money. What about the failover and the scalability that I touched on? How can we do that seamlessly? Okay, without having to get someone in at whatever hour of the day or night to reboot an instance and fix it. And how do we actually even get the traffic balanced across multiple firewalls when it's going out? It's pretty straightforward for ingress traffic coming in from the internet. You've got a public ELB, traffic hits it, and it just goes you. Okay? A little bit trickier when we're doing it for outbound traffic. So, can we use internal ELBs pointing to a firewall pair? So, if you want to go to the internet, can you route to an ELB? No, you can't. And I've got a slide to show you what that looks like when you try. Can you possibly use an explicit proxy? Yes, you can do that, but it can be a bit of a pain. A lot of the requirements, particularly for EC2 instances, is to not have to deal with explicit proxies. Sometimes it's because an application needs to get to the internet and it's a real pain to configure it to go via an explicit proxy. So a transparent proxy is really, really quite advantageous. So this is what it looks like when you try to enter a load balancer in a routing table. Okay, it's going to come up and say, select a target for a valid resource ID. So I've got this load balancer that I created called PG internal, and then when I've tried to go to that in the route table, it just doesn't like it. Okay, so you can't actually route to a load balancer. Okay, so that's a big no-no. What about some other options? So I've mentioned explicit proxy a couple of times. Yes, you can do that. Okay, but it could be a pain from an application perspective. It may be a hassle, and a lot of the time, it's just going to be easier if we just use a transparent proxy, if we can. Okay. What about scalability? Okay. What about high availability and failover? Yes, there are ways we can achieve that. And the solution that we identified was to kind of take the idea of an ELB and make our own. And this was what actually this organisation's adopted. So the actual way we got around that was to create what we call an outbound gateway, which is essentially a load balancer. But what it does is you put it in a subnet, in a paired VPC, and it will talk to the firewalls, to the UTMs using a tunnel. Now, that allows you to then route to it and send traffic through transparently to the firewalls. So, that little diagram that I showed you earlier with the transitive pairing restriction, we can basically tunnel through that pairing connection. So even though VPC-B doesn't have an internet gateway, we've got one of these little routing instances called the outbound gateway, and our route table has that as its routing point. So if you want to go to 0000, go to this ENI. And you hit the ENI, and through you go. So that could be application traffic, it could be browser traffic, whatever the case may be. Now, the tunnel is back to a cluster of UTMs/firewalls, and effectively the traffic hits the firewalls with the source IP address of the client system reserved. Okay, so then you can say, well, okay, from a firewall perspective, is this allowed? From a web traffic perspective, is this allowed? Try again. This is my high-tech artwork diagram. So I haven't used too many actual marketing-approved diagrams. I made my own. But this is what it looks like in a very simple context. And this isn't within a single VPC. So this, whilst it was designed for a solution or for a requirement which was across VPCs, you can actually use this quite easily within the local VPC where your firewalls are located or your UTMs are located. You just pop one or more of these outbound gateways in their own subnet. You then update the routing table for your clients to say, if you want to go to the internet, go there, and then traffic will go through the UTM. So from a point of view of getting to the internet, no problem. High availability, yep, we can do that. We've got a couple of boxes running there. Failover, yes. Transparent, importantly, yes. What about scalability? This is the other thing. So that's great that we can split it across a couple of instances or firewall instances. But what happens if the traffic really starts to ramp up? So this is where we actually have auto-scaling groups, and our UTMs sit in the auto-scaling group. We use S3, so configuration is sent to an S3 bucket. When a UTM launches through auto-scaling, what will happen is it will download the configuration from S3 and add it in basically to the files config straight away. So that normally takes a couple of minutes from the time that the instance starts. So from an auto-scaling perspective, yes. Self-healing, if one of these boxes falls over, it's not a problem. We're monitoring them with CloudWatch. We will see that one of these firewalls/UTMs has stopped responding. Auto scaling will then launch a new one. Okay, so it's self-healing, and because we're using S3 and CloudFormation and a few other things, we basically support DevOps continuous delivery environments. So tick there. And of course, extending this across VPC. So I've already talked about the fact that this was designed primarily to work across paired VPCs. We could do that as well. So the good thing is that the tunnels, the GRE tunnels, question?
You can finish your sentence.
Yep. So the good thing about the tunnels is they're nice and easy, they're stable, there's not a lot of overhead. We could do, you could use IPsec tunnels as well, but this is just more overhead. So this is nice and simple. Yes?
My question is regarding the dark blue box, which is kind of a net in this case. Kind of a, and you mentioned about ENI. I suppose it's in the routing table.
Yes.
So if that machine falls over, what if the machine itself is not can't keep up with the traffic?
Yeah, good question.
And how do you dynamically, because the ENIs are fixed, right?
Indeed. So part of this technology is that the UTM can actually talk to the route table. So you don't necessarily just have one of these gateway instances. You can have multiple, and they've each got tunnels back to the UTM cluster. Okay. Now, if one of them fails, they're being monitored. Okay, so there's a check every 30 seconds or so to say, are you there? And if there's no response, it'll go, oh, hang on, this one's fallen over. It will then update the route tables to say, you guys down at the bottom, it's got a laser pointer, but you guys down at the bottom, you need to go to this other one. So the route table gets updated with a failover one. If you've just got one, sure, it's going to fail. If it fails, it's going to stop traffic. Right?
Did it happen?
Not as far as I'm aware. All right, so across VPCs, yes, definitely. This is the marketing official diagram of what the whole solution looks like. So those UTMs that I showed you, they're actually what we call workers. They handle all the traffic going in and out. We actually have another UTM which sits to the side, also in an auto-scaling group, which is called the controller, that's where we do all the configuration. The controller stores the config in S3, and the workers will be polling the S3 bucket regularly to say, okay, is there a new rule? If there is, I'll download the config. And the blue boxes, those outbound gateways, as we saw previously, sitting between essentially the client subnets and the UTM workers. All right, so what it actually looks like, it's a Linux instance that we've basically modified and created our own load balancer, if you want to call it that. That's what we call it in the CloudFormation template when they're launched. So it's got, it's got an IP address. It's got, of course, it'll have an ENI. So we can see that the name's load balancer, LB. Looking at the actual details of the network interface, just to show you that it's ENI 5615152B. Okay, so just remember 52B. So that's the ENI, and then in the routing table we can see the same 52B. So this is just showing you that it's the ENI of the load balancer in the routing table. Okay, so any requests to go to the internet within the subnet that's got this particular routing table will go straight to that outbound gateway. It will then just send the traffic through that GRE tunnel, hit the UTMs, and then they'll do whatever they do. And what it looks like if you're running on a, let's just say a Windows box, an EC2 box, you open a browser, and this is just to show that there's no proxy server. So this is transparent proxy. Okay, so no proxy server there, but I can get to sydneymorningherald.com. And this is only a few days old because they talk about Harvey. And that, I think, is it. Any questions? Yeah.
With the outbound gateways, you've got a couple of new manually initiated failover if you want to use, say, patch one of them.
Yeah, easily. You just shut it down. Or you turn it off, because within the actual console, there's a little switch to say, here's this outbound gateway, turn it off. Okay, so then the UTM will stop talking to it.
Yep.
You can then go and do whatever you need to do to the actual instance, and once you've maybe rebooted it, go back to the console, turn the switch back on again, and within about a minute, it's re-established the tunnel, and you'll see it change from down to up.
So when your outbound gateway goes down, who actually advises the clients that their outbound gateway has changed the address?
So that's where the UTM, or that controller UTM, it is in communication with AWS. And so when you define these, you say these are the subnets that I want to protect. Now, there's stuff under the hood in the UTM which talks to AWS resource management. So it will then say to AWS, for these subnets, I want to change the route table. Okay, and it will change the route table. So if one of those instances fails, then it will, through the monitoring, realize that it's failed. It will say, okay, this is a failover for that. It's create failover groups. This is the failover instance. We'll update the route table to point to the ENI of the running gateway. All right. I'm sure everyone's keen to see who wins those drones. We're not allowed, are we?
That was all, Peter. Thank you very much.
Thank you.
One thing I just found out last week is that Sophos has a free downloadable version for Mac, NDB for Mac and stuff that I didn't realise we even did.
Yep, Sophos Home, and it's free. You're probably familiar with crypto stuff, like ransomware and so on. We've got stuff coming to Mac to protect against crypto. Got that in Windows already.
Awesome.
Yep.
Yeah, that's very cool. Right. So I didn't even know you did that. Thank you very much, Peter. No more questions? Cool. All right.
Okay. Thank you.
I'll kick off with the next. Is there another slide? Oh, win a drone prize. Anybody here for a drone? No?
Yep.
Yes, just one? Okay. Where's Gary? I think he's done something. Ooh, the magic bucket. Can we get somebody else to pick one? How many am I picking? Cool. So, Sam Redmond. Sam Redmond. Thank you. here tonight?
I'm a recruitment consultant. I'm coming in 3 days ago with Saris.
Okay, cool. Congrats. Good first turn out there.
Yeah.
Good work.
Cheers, mate.
One moment. Wait.
Thank you.
Congratulations.
Jonathan Fu. Jonathan Fu, where are you? Are you not here? Oh, no? You're not putting your hand up? I got it right? No? Okay.
You sent me a message actually.
Oh, did you really? Of course you did. Yes. Good call, Simon. Good call. Imran Dawood. Imran, yes? Well done. Good stuff, thank you. Yeah, what do you think of tonight? Enjoy it?
Yeah, just to learn more about AWS here.
Yeah, cool. And who are you working for?
I'm working for Ingenico.
Ingenico?
Yeah.
You guys using AWS?
We were actually offer financial solutions
Yep, cool.
and the pin pad terminals which we use on tools and Sophos.
Okay, great. Thank you very much. Well done. And that's it, everyone. Thank you very much. Same time, same place, next month.
Thanks.
Next month we have Cloud Elves and Convols brought to you by PolarSeven. Thank you all for coming. Hope you enjoyed it. Update us on the meetup with any details or updates that you want us to do, but see you next month. Take it easy.